Hi everyone, welcome to week 6 of your college algebra class. This week we're going to be covering chapter 7. Chapter 7 is all about graphing functions and then applying those functions. So as we start, the first thing you're going to need to know is the definition of what a function is. And as you read through the chapter, they're going to define function. And the best definition that they use is that it's a correspondence between two sets of numbers. So there's only one number in the range that matches up with the numbers in the domain. And that's a great technical kind of a definition. But what I like to think of when I think of the function is we actually talk about a function machine. And here's just a little graphic that your book uses. But basically the idea with a function machine is this. When you put something into it, you're only going to be able to get one thing out. So if you put a value in for x and you get more than one y, that's not a function. So the key here to identifying a function is if you put in a value for x, you only get one value for y. And that's every single time. So you put in something for x, you only get one y. That defines the function. So when we're looking at an equation, that's the way to tell. We can also look at a graph. And if we look at a graph, we can use something what they call the vertical line test. And basically what that means is if the vertical line, and vertical is an up and down line, right? So if we can put an up and down line anywhere on the graph and cross more than one point, then it's not a function. So your book gives you several examples, and here's some in the PowerPoint. Notice on the first one, that up and down line can cross up to 3 times in one spot. So that is not a function. However, on the second one, we can move that line anywhere along that graph and it only crosses once. So that is a function. The second one again the third one is a one where you can put an up and down line and we're going to cross more than once. So that one is not a function. So there's the vertical line test, so that up and down line to test whether or not it's a function. And then there's also the function machine. In other words, putting in an x, seeing how many y's come out. As long as it's a one-to-one correspondence, we're good. So that's what they're going to cover in all of section 1. As we get into section 2, we're going to actually look for how to find those pairs. So we call those the domain and the range. So you can think of the domain as the x's, the range as the y's. And so we're going to go through and look at how to find all of those pairs or those sets of pairs for any particular function. So that's what section 2 is going to be all about, is finding the x's and y's that will make a function true. Okay, and again, just think of it as input, output. X's are what you're putting in, y is what's coming out. The third section then gets into linear functions. So we're going to kind of go back to what we already had talked about with graphs of lines, using that y equals mx plus b form, finding the slope of a line. So what they're really saying is a linear function is simply a function f of x where it equals mx plus b. So it's not changing what a linear function looks like. It's just using that f of x terminology in place of the y. So we're not really changing anything. We're just using f of x to represent the y. So so nothing totally new here. You're still the m is still the slope, the b is still the y-intercept. We can still plot points by putting in a value for x and solving for f of x. Again, it's just f of x is another name for y. Okay, so just kind of keep that in the back of your mind as you're looking at this. They're going to have you looking at how to actually calculate slope. So if you're given 2 points on a line, how do we find that slope? So we're not just identifying it in the equation. We're looking at a line and finding slope. And slope is just defined as vertical over horizontal change. So difference in y's over difference in x's. So they will go over that with you in section 3 as well. And then they're going to just talk about how to put it into different forms. In other words, rearranging it to make it look the way we want it to look. And then we're going to use some examples like this. Here's Wanda's hair salon. And they're going to look at how we can apply that information. In other words, we can look at, in this case, how many haircuts per hour we're able to do, because we're comparing the time and the number of haircuts. So they're just looking again at applications of this particular type of equation. Then section 4 is just more on graphing the linear equations. They're going to use the intercepts. So in other words, we're going to look for the x-intercept, the y-intercept, and remember we only need 2 points and a checkpoint to graph. So that's what section 4 is going to be all about. And then let me see, they're going to look at parallel lines and vertical lines and the relationship between their slopes. So parallel lines always have the same slope, but different y-intercepts. So they're going to look something like this, where the red and blue line never cross. So they have the same slope, but they cross the y-axis at a different point. And then we also have perpendicular lines. Perpendicular lines are going to cross each other. They form a right angle. So the idea behind a perpendicular lines is that their slopes, when you multiply their slopes together, you're going to get -1. They're opposite inverses is what we call that. So if the slope of one line is 2, the slope of the other line is -1/2. Flip it, change the sign. So that's what section 4 of chapter 7 is all about. And last but not least, section 5 is applications. So we're going to take all of this information that we learned in the first 4 sections, and we're going to apply it to some specific instances of, things like, what happens if we charge somebody so much per hour and things along those lines. So at any point during this week, as you go through chapter 7, if you have any questions, please make sure you reach out to me. As always, email, call, or text. My number is 618-792-2293. Have a great week.